Yeah, good evening, students. Am I audible? Hmm?
Yes, sir.
Yes, sir.
Okay. So we were discussing three-dimensional geometry, no? I remember completing. Equations of line in three-dimensional space, right? Then I asked you to solve the exercise also. Is there any doubt that you have? Did you all try it? Any doubt? So for that silence, can I take it as no doubt? Okay. Shall I start with plane?
Sir, in our school, they told that plane is deleted, sir.
1 minute. Yeah, I think it is deleted. Correct. Let me check. Oh, yeah, you're right. I forgot. So XII Math.
Sir, it's actually deleted, sir.
No, let me check it once. When I saw it, yeah, I remember it being deleted. Correct. It's not there. So we are done with 3D work. Okay. So we are left out only with two chapters then, linear programming and probability, right? Shall we get started with that? Bounded, unbounded, feasible. Okay, I'll do one thing then. I'll start probability. Okay. And lastly, we'll do that linear programming. Linear programming is only one class, so probability is more important. So let's concentrate on that. You're able to see my screen? Can I have some response?
Yes, sir, it's visible.
Yeah. Okay. So just give me a minute. So before I start this chapter, right, I need to revise certain concepts from your 11th grade. So I'm just taking out the 11th standard textbook. Just give me a minute. One minute. Yeah. See, why I told we need to revise is because in this chapter, we need a lot of basics of your set, the concept of set that you have learned in your 11th standard, right? So tell me one thing. You know that experiments are basically classified into two types. What are they? One is called deterministic, and the second is called random. So when you're studying probability, right, what are the type of experiments on which we concentrate? Is it deterministic or random? So what do you mean by deterministic? The name itself suggests you something. Deterministic means you can determine the output. Means it is sure 100% of what you're, 100% of what result you're going to get. Whereas when you talk about random experiment, there is different possibilities for different events that we are going to perform. Am I right? So when you talk about them, right? When you talk about a random experiment, there is something called as a sample space. So what is sample space? So what is sample space?
All possible outcomes.
How do you write it? It is a set of all possible outcomes. Am I right? So set of all possible outcomes is what is called as a sample space. And how do you represent it? See, for example, if there is a possibility of you throwing 2 coins at the same time. So if I ask you to write the sample space, how will you write it? S will be equal to, tell me.
Tail, head,
Okay,
head, tail, head.
right. So this is how you're going to write the sample space. So you already know this, right? The next is about, you need to know what is an event. So what is an event? So what is event? Each outcome of an experiment can be called as event. Okay. And this term event is very, very important for us to understand the chapter of your 12th standard, because we'll be discussing, or you need to choose what kind of events are they to apply a particular formula or a condition to that particular problem. So you need to know what is a event, right? So what are the different types of event that you can talk about? So what are the different types of event that you can talk about? One is impossible and sure event. So what is an impossible event? As the name suggests, impossible event has a probability of 0. For a sure event, what is the probability? It is going to be 1. Right. Next is a simple event. So what do you mean by a simple event? So what do you mean by a simple event? If an event has only one sample point, then it is said to be a simple event. For example, tell me the example of a simple event. For example, let's take the concept of tossing a coin. Head, 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 tail, head, and tail. Right. So when can I, so this is a sample space. When can I say a particular event from the sample space is a simple event? Can you tell me? When I define an event even as head, can I call this as a simple event? Yes or no?
Yes, sir.
Right. Now, so what will be the opposite of simple event? You can call it as a compound event. So what is a compound event? Opposite of simple. Simple is the event has only one sample point. So what will a compound event be?
Multiple sample.
So which has multiple sample points is called as a compound event. Right. It's called as a compound event. Okay. Next is See, all these things are from your 11th standard. Okay, that is why I'm going a little fast. Next is algebra of events. So when I talk about algebra of events, what can you do? So from the concept of set, we know that you can either perform union or intersection to do different kinds of operations between the sets, right? Similarly, in the case of probability, you can define complementary event. So what is the complementary event? So complementary event is also called not of that event name. For example, if I say there is a sample space of tossing two coins, head, head, tail, head, and tail. Okay. If I'm defining an event A, my wish, where I'm saying at least one head is there. Can you define that event? At least one head is there. So what should I write in this? What are the sample points I need to take? HTTH. HTTH and
HH.
HH, because I told at least one head. It can either be one head or both heads. So if I call the other event as TT, what do I call this TT in terms of A?
Not A.
So it is called not A.
Complementary.
Or write it as A complement. How will you write it? A with a prime on top of it. Can I call it like this? Yes or no? Right.
Yes, sir.
Second, the event A or B. So how do you write event A or B? So let's say or means what?
Union.
Union.
So A or B. Third, the event A and B. What will it be?
Intersection.
Right. Next. The event A but not B. Tell me. So
A minus
event
B.
A minus B. And how can you write it in terms of union or intersection? It is going to be A should happen and intersection means and B should not happen. Can I write it like this? Can I? Right.
Yes, sir.
Now I have an example. So example is consider an event of rolling a die. I want everybody to try it along with me. So there is an event of rolling a die. Let A be the event of getting prime number. And remember, events are represented by the symbol by the uppercase. Okay, A be an event of getting a prime number, and B be the event of getting an odd number. Event of getting odd number. Okay. Write the set representing the events A or B, A and B, A but not B, not A. Okay. So for that, first we'll write the sample space. Answer my question. What is the sample space? 1, 2, 3, 4, 5, 6. Okay. What is event A? Elements of event A. 2.
Sir, 1, 2, 3, 5.
1 is a prime number, Ada.
2, 3,
sir.
5.
Yes, sir.
Yeah, 2, 3, 5, no. 2, 3, 5. And what about B?
1, 3, 5.
1, 3, 5. Now can you tell me A or B? A or B means
1, 2, 3, 5.
Sir, 1, 2, 3.
1, 2, 3, 5. A and B means
2.
right.
Three.
A lium B lium, what is common?
3, come on.
Third, I'm writing it here, concentrate. A and B dash. So for that, I need to define what is B dash. What is going to be B dash? 2, 4, 6. Correct? So what is common in A and B dash? Is it 2? Guys, are you able to understand?
Yes, sir.
Fourth, not A. Navdina? 1.
1, 4, 6. Sir.
That's
Sir,
oh,
sir, for A minus B, can you draw that Venn diagram, sir?
A minus B. See, this is A. Okay, this is B. Okay. Now you are going to tell me that. This A nedutha, this B nedutha. I'm using yellow for A. This full A va.
Yes, sir.
Okay. Red for B. This full B.
Yes, sir.
Okay. Then where is B complement? Where is
A
B
minus
comp? Okay, I'll use a different color for it. Either ka. So what is this part actually?
intersection.
Intersection. So where is B complement? Idua.
Yes, sir.
So A intersection B complement on the region.
Okay, sir.
Purida. Shall I proceed? Okay. Now comes the important concept. See, these two terms are very important. Okay. There is a theorem called Bayes theorem, which we'll be learning. In that, you need to know that these two events, I want everybody to focus. One is called mutually exclusive events. Okay. So, if A intersection B is a null set, means if they are disjoint sets, then A and B are said to be mutually exclusive. Okay. Means if I have two events A and B, and if those events A and B do not have any common point between them, then they are said to be mutually exclusive events. Can you give me an example? Let us take an experiment of rolling a die. If I define an event A of getting odd numbers, and if I define an event of getting even numbers, can I say that these two events are mutually exclusive? Can I?
Yes, sir.
Understood what is mutually exclusive? Because we'll be discussing something called as independent also. That is different from exclusive. Guys, is everyone clear? This word is important. If you're clear, I'll proceed. Right? So, Mari.
Yes, sir.
So, see, everything I'm explaining only from your NCERT, okay? So just in order to save time, you can take a screenshot and just have it from whichever device you're watching. exhaustive events. So name is suggesting.
sir.
What do you mean by exhaustive events? If A union B is equal to the sample space, means you have elements from set A, you have elements from set B. If the union of these two means if you combine both the elements and write, then you get the sample space, then A and B are said to be exhaustive. Why do we call it as exhaustive? Because what do you mean by exhaustive list means you have utilized everything. Okay. So tell me one thing. What is going to be the probability of A intersection B if A and B are mutually exclusive?
No, sir.
Null set.
The null set என்றது A intersection B. Probability of A intersection B will be 0.
0.
புரியுதா? So what will be the probability of A union B if A and B are exhaustive?
1.
It will be 1, means because they are sure event. So A intersection B is going to be an impossible event. A union B is going to be a sure event. Right? So having this in mind, I'm going to give you an example. Right? You're going to find. Tell me.
So what are two events called which are mutually exclusive as well as exhaustive?
It's not like that. They're independent. Okay. You need
No,
that
sir, because in the previous case which you took, like the 1, 2, 3, and 4, 5, 6, those are mutually exclusive, but they're also exhaustive.
exhaustive, right? So there is no special name for it. You just treat them independently. There is no, like, I'm able to understand what you're asking. Like a one-to-one function and onto function combined together is called bijective. So there is no name to it, to my knowledge. Okay.
Okay, sir.
1 minute, I'm getting a call. Just give me a minute. What were we discussing? We discussed about exclusive and exhaustive, right? I'll give you an example. Example 7. Okay. So 2 dice are thrown. Okay, 2 dice are thrown, and some of the numbers are noted. Okay, some of the numbers means some of the numbers on both the dice are noted. So there are multiple events that are defined. A is sum is even. B is sum is a multiple of 3. C is sum is less than 4. D is sum is greater than 11. Okay. Which pairs, listen to this question carefully, which pairs of the events are first mutually exclusive? See, when you use the word mutually, they are exclusive. If you don't use the word mutually, they are only exhaustive. Don't call them as mutually exhaustive. No, that is wrong. Okay. So can you guys tell me? I'll give you a minute
So the
time.
first one is D and C.
Mutual exclusive. Huh?
Yes, sir.
Okay. So can you tell me what is going to be the sample space?
Sir, 1, 1, 2, 1,
Should I write it like this? 1, 1, 1, 2. Should I write
2.
correct? And I
Sir, ordered pair.
it is ordered pair. Purida. Like this, what will be the last element?
Sir.
1,
Tell me.
6.
Sir, but
Tell me.
how is this a sample space? Sample space is a sum, right?
Sample space is always taken from the overall experiment. From the experiment only you define the events. See, Subrajit, there are two terms, okay? Da? Listen to this scale. Random experiment. Okay. The sample space that you're writing, no, that is the output of the random experiment. From that random experiment, you will take subsets, no? Those subsets are the events. Am I clear?
Yes, sir.
Yes. So sum is even as a subset of the sample space. So sample space is going to consider 36 elements. 2, 1, 2, 2, so on till 2, 6. Like this, if I keep on going, the last element will be 6, 6. Am I clear with this? If A is the sum is even. So for the sum to be even, I need to take the ordered pairs in such a way that both the elements are odd or both the elements are even. So what will be the elements I need to consider? 1, 1, 1, 3, 1, 5. Then what should I take? 2, 2, 2, 4, 2, 6. Then what will I take? 3, 1, 3, 2, sorry, 3, 3, and 3, 5. So like this, I keep on writing. What will be the last element that I'll have? 6, 6. So like this, how many elements do I have? In this, how many elements do I have? I have 18 elements. Am I right?
Sir.
Ah.
Sir, but shouldn't the elements be 9? Because they haven't said that the order matters, right?
You cannot take it like that. Order does matter because both the dice they are not the same. Order matters here. If you number the dice as 1 and 2, the sum of the numbers on those two dice should be an even number. That is the meaning. Okay. Then sum is a multiple of 3. Can you tell me the elements of event B? So if I start with 1, the second element should be 2. If I start with 2, the second element should be 1. If I start with 1, the second element should be 5. If I start with 5, the second element should be 1. Right? Then if I start with 2 is over, no?
3, 3.
2, 4 is also there, no?
Yes, sir.
So we'll do one thing. We'll write it in our order. Let's make it simple. 1, 2. 1 minute. Huh? Can you guys write it? I have some important call to attend. Sorry for that. Can you please try it? What were we discussing? 2, 4. Then what do we have? 3, 3. 2, 1, 2, 4. அவ்வளவுதானே? So 3, 3. With respect to 4, 4, 2, and anything else? And with respect to 5, you have 5, 1.
Sir, 4,5.
Sir, 4,5, sir. 4,5.
4, 5. Is there anything I'm missing? 3, 3, 4, 2, 4, 5. 5, 1 is there. 5, 1 got 5, 4. Then what about 6?
6, 2, 6, 3.
6, 3.
6, 6.
அவ்வளவுதானே? So where in what is C? Sum is less than 4. So sum is less than 4 means
Sir, 3, 6 is also there.
I missed 3, 6. Okay. Sum is less than 4 means 1, 2. 1, 2. 1. Sorry, 1, 1, 1, 2, 1, 3 will not come. That's it, no? Then you have 2, 1. Everything else after. So they told less than 4, then strictly less than 4. Sum is less than 4. Okay. So these are the 3 elements. And D is what? Sum is greater than 11. Greater than 11, now what do you have? 4, it will not work. So 5 will also not work. So only option is
6,6.
Okay, now tell me which events are exclusive. Like how he told C and D are mutually exclusive. What about B and C? They are not, because you have 1, 2, 1, 2 in common, 2, 1 and 2, 1 also in common. Similarly, B and D, you have 6, 6 in common and 6, 6 in common. Okay. What else is there? So they are exclusive. Then what are exhaustive events here? Oh, they asked only exclusive, but they didn't ask exhaustive. Here, I don't think you have an exhaustive list, right? Because they are randomly split. You don't have an exhaustive. So I hope you understood what are exclusive events, right? And
Sir,
tell me, Pam,
sir, A and B are exhaustive, right?
are they?
Oh, no, sir. 6, no, sir, it's not. Okay, no.
Okay. So this is all from your last year's concept. 1 minute. I need to explain the probabilities of those events. So probability of A union B. Okay. Can you tell me what is the formula? Probability of A union B is probability of A plus probability of B minus probability of A intersection B. Am I right? Why is it so? Why is it so? Because if I take this to be the set A and red color one to be the set B, then what is this? This is going to be A intersection B. Okay. So the number of elements in A, or I will write it like this. Can I write it like this? See. The number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. Why am I doing it?
Sir, since A intersection B is included in both A and B, so
It's
we are
included
subtracting.
twice. Yes. So divide with number of elements in the sample space. So n of A union B divided by n of S is equal to n of A divided by n of S plus n of B divided by n of S minus n of A intersection B divided by n of S. Okay. Kindunda. So what is this thing? It is probability of A union B is equal to, this is probability of A plus probability of B minus probability of A intersection B. If A and B are mutually exclusive, what can you say? Probability of A union B will be equal to probability of A plus probability of B. Why is it so? Because probability of A union B is going to be 0. Is the point clear? Is the point clear? Okay.
Yes, sir.
Students, I have an immediate call to be taken. Okay. I'll stop with this for today. And in the next class, I'll start with your 12th standard. So I hope the basics are revised, no? So have these basics, if possible, just go through your 11th standard content before you come to the class tomorrow. Just go through the concepts. That's not needed that you need to go through everything in detail. I'll explain in detail, but go through the concepts and come tomorrow. I'll start with the concept called as conditional probability. So for you to understand conditional probability, we need to have the basics of these things, which I've already completed. Okay. I'm really sorry I have to wind up because I have to take another call. Okay, I'll see you all at 6 o'clock. Those who are there in the physics batch. Okay.
Okay. Thank you, sir.
Thank
Yeah.
you, sir.
Thank you, sir.
Yeah.